Good afternoon. My name is Lawrence Linick. I'm a program manager at Northrop Grumman and a graduate of electrical engineering from the University of Pennsylvania. I'll be presenting a rationalist theory of extraterrestrial intelligence. Does extraterrestrial intelligence exist? And why haven't I met them? These and similar questions will be answered in this presentation. First, I'll point out some credit is owed to Nobel laureate Enrico Fermi, who invented the nuclear bomb and for whom the term Fermi paradox has been coined. He discussed this and came up with this concept during his lunch breaks while working at labs that were developing the nuclear weapon. Today we'll be discussing the vast extent of space and our tiny place in it, life on Earth and our tiny history of it. Three gentlemen that are prominent in this subject, in my mind at least: Tsiolkovsky, a Russian scientist and mathematician; Enrico Fermi, who we already talked about; and Frank Drake, an astronomer. Then we'll be contrasting the empirical, stochastic, and rational methods of arriving at truths or understandings. We'll look at the zoo hypothesis and conspiracies. We'll talk about filters and a term I've coined called the Fermi irony. We'll talk about that more later. And last but not least, of course, we will discuss the rationalist theory that I am proposing here. Where are they, and why haven't we met them? This discussion will be held in three parts. The first part I call setting the stage. Let us set the stage. The stage, of course, in this picture behind the words, is our universe in toto. All 13.8 billion light years of it. There are 1 trillion galaxies. Think about that. 1 trillion galaxies. 100 billion stars in each galaxy. That equals 1 with 24 zeros after it, 10 to the 24th planets. At least, if not more. Could be multiple planets around each star. And there we are, over there. You can't see it. I'll move a pointer over here. This little speck is us. We occupy one of those planets in this great big universe. And I believe that the odds are about at least 1 trillion to 1. Evidence points to them being at least 1 trillion to 1. Could be greater, but probably no less. We'll talk more about why I believe that later on. First, just to set the stage a little bit and understand the scale of the universe. Our solar system, which I'm defining as 1 full light year away from the sun, which is huge, way beyond anything that we've ever explored, but still within the scope of the influence of the gravity of our sun, is this little tiny dot. You can barely see it. This whole green bubble here is what I'm calling our 1,000 light year local area. 1,000, anywhere from 1,000 years surrounding our solar system, 1,000 light years, or 1,000 years at the speed of light. That's our local area. That green dot, that green bubble, that massive, huge 1,000 light year green bubble is just this little tiny speck inside the whole Milky Way. It's 1/100th of the Milky Way. And then, of course, our Milky Way, this blue bubble, is this little tiny dot, this little tiny blue dot, 1/100th about, of a 10 million light year region of the universe. A 10 million light year region. Our galaxy is this little bubble. Andromeda is this other little bubble. Andromeda is pretty far away. It's 2.5 million light years away. And this whole bubble is 10 million light years in extent. But this little bubble here, this red region, 10 million light years in extent, is this tiny, tiny little speck in the corner of the entire universe. And this piece of the universe, which is highlighted here in this little inset, is only 1/10 of the whole universe. So this little speck is 1/1000th of the entire universe in extent. It's 1/100th of this whole corner of the universe, and this whole corner of the universe is 1/10 of the entire universe. I'm calling that 1.5 billion light year corner of the universe. Still just a tiny part of the universe, 1/10 of it. And this is 10 million light years. Hopefully that helps you get your perspective wrapped around distances. We'll do a similar analysis of the time scales. The universe is 13.8 billion years. Mankind only showed up about 100,000 years ago. So to drill down on that, we know that other galaxies, early galaxies, formed way before our galaxy, the Milky Way. Milky Way is only 4.6 billion years old, about a third of the age, a little less than a third of the age of the entire universe. Other galaxies existed way, way before us. And note that life started only about 1 billion years after our galaxy and our solar system formed. So life popped on the Earth fast. Life itself. Life probably formed in other galaxies earlier as well. Maybe dating back all the way towards the beginning of the universe. At least 13 billion years ago. And at least, well, if we're just talking about man, at least 13 billion years before man, life started. Now, land animals, and it's animals that have progressed to multicellular level and moved out of the oceans, they started occupying the land only about 300 million years ago. So this tiny little mustard yellow slice of the total amount of life on Earth, which was primarily in the seas and primarily single-celled life. And then the earliest hominid, we're talking about chimpanzees, the apes, the great apes, orangutans. The earliest hominid is just this little tiny red sliver. You can barely see it 2.5 million years ago. Now we look at the whole span of land animals and we see that earliest hominids is just this tiny red sliver of that. So land animals, all multicellular, simple land animals, worms, things that lived on the land, occupy this amount of time. Megafauna and dinosaurs go back 100 million years, a third of this. But the human race is descended from a hominid genus emerging 2.5 million years ago. And then modern man is still even a tinier sliver, this little blue sliver of nothingness in the scheme of land animals. Now we drill down, we take this red box and we make it much longer. And here's modern man, only 100,000 years existing on this planet. And of the existence of modern man, let's face it, modern man has lived in caves, without language, without sophisticated tool-making capability, barely scraping by and surviving, as chimpanzees and gorillas and orangutans do now. For the bulk at least 90% of our modern man existence on the planet has been no recorded history, no writing, no reading, very primitive, limited tool making. The Neolithic civilization, the period in which we started agriculture, started writing, is only 10,000 years old. And then 90% of that was just pure superstition, mystery, the unknown. Who knows what man back here 90,000 years ago thought? Much less Neolithic man, early Neolithic man, 10,000 years ago, about the sky and the stars, the movement of the celestial objects. Surely he thought of those things. But the age of science is only 10% of that entire period, about 1,000 years, not even. And now we come to our modern time, less than 100 years duration of radio communication, launching rockets into orbit, 50, 60 years, not more than that. The scope of this 100-year period that we've experienced in the last 100 years, the explosion of technology, the internet, rockets, radio communication, all that 100 years constitutes 1 out of 138 millionth of the time of the existence of the universe. 1 out of 138 million means flipping a coin heads 27 times in a row. That's about 138 million to 1 chance. Or, looked at another way, take human hair, one human hair, stack it on top of another human hair. Keep stacking those human hairs. By the time you get to 138 million human hairs, you've gone 6,000 miles of stacked human hairs. 6,000 miles. That's the fraction of time that humanity has been emergent, what I call emerged. We've emerged from our cocoon. We are now part of the greater universe, emitting radio waves out into space, launching rockets from our surface of our planet. What do we need to consider about these scales of time and distance? What's important here in this question about the existence of others somewhere in the universe? Well, first, the universe is very old, very large, very old and very large. We occupy a tiny, 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 tiny sliver of distance. Even our furthest exuding radio waves that were emitted in the early 40s have only reached about 100 light years out into space. That's still a tiny, tiny fraction of the total distance. And our time frame, even a million years or 100,000 years of modern man is just the tiniest fraction of time. Now, all that said, our Milky Way, the galaxy, the place that we usually think about as our universe, our Milky Way galaxy, is actually very near to us. It's only 100,000 light years in total extent. It's completely static. When they talk about the expanding universe, the universe expanding, the metric of the universe expanding, the galactic metric is not expanding. The galactic metric is static. If it's expanding so slowly and so minimally that it has no impact in any kind of human timescale. It's basically static. The Milky Way is the Milky Way and has been for all of humanity, for all of time, and will be for the foreseeable future. So the Milky Way could be occupied. We could travel to the ends of the Milky Way galaxy, given enough energy and technology, etc., and time. We could get there in millions of years. Millions of years is a finger snap compared to the entire history of the universe. But the universe is a different story. When we start to look out beyond our galaxy to other galaxies, and not just the local galaxies, the ones that are way far away, billions of light years away, hundreds of millions of light years away, those galaxies appear to be expanding, moving away as the universal metric increases. Those galaxies are ever expanding away from us, some at the speed of light or close to it, or maybe even more than the speed of light, depending on some universal constants that are unknown today. But we know that we could never catch up to the edge of the universe. It's impossible. We know that light itself is expanding, and that light is making the universe get larger and larger every year, 1 light year larger. And therefore, we could never reach the end of the light cone of the universe because we could never exceed light speed or even approach light speed on aggregate, in average. And therefore, it's impossible to occupy the universe, impossible to explore it. No one could get into a spaceship and go to the end of the universe in any amount of time. It's impossible, ever, because it's continuously expanding, like this car that's driving less than light speed, and the universe is expanding at about light speed. It'll never reach the end. That's what we understand. That's what we know from understanding the distance and time scales of our universe. Of course, we have the same questions that ancient man had, that primitive man had, even Neolithic man. But our questions are asked in the modern era. They're asked today with modern science and knowledge of modern things. We've always asked these questions. We've always put forth our own answers. The answers can be seen in the record of art, Neolithic art, and recorded history. But since the advent of modern cosmology, it's taken on new forms. One thing to consider is this graphic over here, this image, this fresco from the medieval times of angels interacting with man. Many feel that medieval man's angels are modern man's aliens. When we think of angels, we think that's ridiculous. That doesn't make sense. Some people believe in angels or the concept of angels, but generally in scientific circles, angels are not recognized as legitimate truth. But aliens could be. But haven't we only substituted aliens for angels in the scientific parlance? It's not a big leap. I think Fermi and Sagan and many others who have advocated for SETI experiments, that's the search for extraterrestrial intelligence, they've sought their answers through science, through what we know as empiricism, or the empirical search for truth, finding evidence and using our observation to look and listen to the cosmos for signs of alien life. The fact of the matter is we have searched the world over. We've searched the skies. We've searched. We've dug into our own ground. We've sent probes to other worlds. And the results are in. Nothing has been found. There is not one shred of hard evidence of extraterrestrial life. Nothing corroboratable, nothing scientific, nothing repeatable, nothing clear and unambiguous. Lots of rumor, lots of innuendo, lots of conjecture, but nothing that we could call hard fact, and certainly nothing to indicate intelligent life yet. So what does this lead us to? It leads us to a paradox, a seeming paradox, I should say. Because Fermi and his colleagues that worked on the nuclear bomb, when they took their lunch breaks, they asked themselves this question, the same question that's been asked for millennia. If the universe is so vast, remember, trillion, 100 billion, 10 to the 24th planets. If the universe is so vast, then it must be teeming with life, especially since we know now that life formed very early in the history of the universe. I should say very early in the history of our planet. We don't know about the universe, but our planet we do know, very early. life form. So if all these 10 to the 24th planets are teeming with life, why haven't we seen or heard from anyone? What's the problem? Where are they? The results of this empirical search, this looking out, gazing out, using radio telescopes and the SETI experiment, have yielded nothing, zero, zilch. So at his wit's end, Frank Drake and others, famous astronomer Frank Drake, came up with a statistical formula. Statistics were popular at that time. They led to the quantum theory, where we statistically analyze matter and the laws of physics. So why not use statistics for this problem? Seems reasonable. They came up with an equation, N. The probability of life equals R, FP, NE, FL, FI, FC, L. Multiply all these factors together, you get your probability of finding intelligent life. The problem is, and I'm going to focus on these values of FL, FI, and FC. What do they mean? The probability of life, the probability of intelligent life, and the probability of intelligent life emerging to communicate and transport itself off its planet into space with other potential intelligent life. These three values I'll show are of an unknown product, unknown value. We'll talk more about that in the next section.